Alright, again, picking up right where we left off. So, yeah, it's going to, um, it's going to set that to being flagged true as we've reached our maximum size. So then on the next whole loop through here, it'll get checked and it'll say, have we reached max size? And in this case, it'll be like, yeah, we have. So we come up here and we check first to see if it's equal to our most recent decal, because our most recent one, we don't want it to shrink. We want it to only shrink the decals that are not the one right under your feet. So we check that, and if that is true, then we'll come in here and we decrement it. So we just decrement it by that same amount of time. You get fancy and play the increase, the ramp up and ramp out. You could change these, but for demonstrative purposes, this works fine. It'll kind of swell up at the same rate as it shrinks and fades out. So it'll go into that. It'll shrink it a little, and then we do another check and we make sure, have we gone below 0? And if we have, then we will set it equal to 0. And then we come through and we set the scale. On the other hand here, if this were to be false, and this does turn out to be the most recent decal, then we don't do anything to it. We just set the scale. I could probably leave this one blank, like I could disconnect it, but just to make sure it doesn't jam up in some weird way, I connect it. It's not really hurting much. So that's that. That handles the increasing the size and setting whether or not it's reached its max size. And then this handles the scale. So after that is done, after that loop's done, then we come in here and we're going to check the same array. This is, the spots in this array are going to line up with the other array. It just makes it easier here because I have a big Boolean and function, not function, but and check. So we set the current index again, and then what we want to do is we want to check, have we reached the maximum size yet, which would indicate that it's hit maximum size at some point. If that's true, and if we aren't equal to the most recent decal, and if the array length is greater than 1, because, well, technically I don't even need this. Now I look at it, I don't need it, because this would already kind of dictate that. The most recent decal would be, so this is redundant, but and is that point, that index point that we're referring to, is its time or a lifetime less than 0, indicating that it reached maximum size and it decremented all the way down to 0. So if all those are true, then we come through and we destroy that. We remove it from the array of decals, the point array, and we remove it from the lifetimes array and the booleans array. So again, we spawn one in the beginning, then we do a check, a periodic check on tick in this case, to see if we've moved further than X amount of distance away from the last point. And then if we have, we do a trace to see where to put the decal. Then we run a loop. It's going to increase the size, decrease the size once it's reached its maximum limit, set the size of that, the scale of it. Then afterwards, we're going to do some checks to see if anybody has reached the maximum size and if they need to be destroyed. And all in all, that'll work just fine. Actually, I do want to change this real quick just to demonstrate the using a different tick, essentially a way more efficient tick, because this will be updating 60 times a second or whatever you got your frame rate set to. And that might be a little overkill for something like this, so we are going to replace these with, you can find the second one. I'm going to replace these real quick with the delta, or the delta seconds with the timer tick. So as you can see, it still functions just the same. The only problem is a little choppy at 10 times. That's at 10 FPS essentially. You go in, you could set this to, I don't know, 0.05. Whoops. Set it to 20 FPS. 20 FPS should be way more than enough for some. Yep, that's way more than enough. You could probably even get away with 15 FPS on something like this. Little optimizations like that go a really, 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 really long way in performance. That's why they, on a side note, that's why they created behavior trees, is because it made it pretty much purely event driven and custom tick driven. That's why on like a behavior tree you can set the like the tick speed, essentially, how many times, how many updates per second, 5, 10, 50, because it helps out a lot with efficiency. Some effects you don't need to run at 60 or 120 FPS. You don't need to run this whole entire loop 120 times per second. There's no need. You would be way better off optimizing it. And so eventually I'll get around to figuring out the what do you call them, the render targets. I'll get around to making a version of this that uses render targets, and I'll probably do another tutorial on it, but I kind of want to find a way to really benchmark the two. So I'll make some kind of overkill system and really crunch the two against each other to see which would be more efficient, to use a method like this with decals, or to use one big giant decal, but it has to update a render target every frame or so. So we'll see, but that's at least the basic gist of this. So it works great. You can see pretty easily that the materials are different. They have different normal maps, different reflectivities to them, and all in all, it works. So hope this helps somebody out, and thanks for watching.